today's video is going to be on how we are going to be reading graphs and functions. So sometimes we are given problems such as these, word problems or questions about a particular graph. So let's dive in. Today's is temperature and time. The graph shows the temperature between noon and midnight in one day in a certain city. We want to know for our first question, is it warmer at 3 p.m. or at 9 p.m.? So one thing to consider is our x-axis, which is horizontal. So our x-axis, which is right here, is going to be our time in hours after noon. So 1 o'clock, 2 o'clock, 3 o'clock, all the way to midnight. And our y-axis is going to be temperature. So what we have here is we have our graph and it's asking is it warmer or at 9 or 3 p.m. So what I'm going to do is go to 3 p.m. and I'm going to go straight up and figure out what the temperature is, which it looks to be between 54 and 55 degrees. So I'm going to guesstimate 54.5 degrees. While at 9 o'clock, so I'm going to start back at 0 and go all the way to 9, all the way up. And what I see here is, it actually is a little bit higher. That's probably about 55.5 degrees Fahrenheit. So is it warmer at 3 or 9 p.m.? My answer is going to be, it is warmer at 9 p.m. Pretty crazy, right? So then our second one here, it says approximately, so about, when is the temperature the highest? So what I can do is, I'm actually going to follow my line here and go boo 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 boo. Oh look, here is my highest point on my graph. Well, the highest temperature is 59 degrees. But that's not what the question is asking. When, meaning time, is the temperature the highest? So I can see that it's about between 5 and 6 o'clock, but it's closer to 6. So I'm approximately going to say it's probably about 5:45. So the temperature is the highest at 5:45 p.m. or about 5:45 p.m. The next question I have is find another time when the temperature was the same as 4 p.m. So what I'm going to do now is go to our 4 p.m. time, which is right here on our x-axis, and go all the way up. And I can see it is about maybe 57.1 or about 57. So I'm actually going to draw a line, a horizontal line through my 4 p.m. all the way across and see what other time is that going to be. If I follow my dashed line, oh look! At 8 p.m. we have the same amount of temperature. So it's about 57. So another time would be the temperature is the same at 8 p.m. So 4 hours later it's about the same temperature, which kind of makes sense if you think about it when we're thinking about days. Sometimes it always hits the same temperature at different times though. So did the temperature change more between 1 p.m. to 3 p.m. or 3 p.m. to 5 p.m.? So now we're going to look at 1 p.m. to 3 p.m. So let me erase these. So the temperature change from 1 p.m. is right here to 3 p.m., which is right here. So I'm looking at these intervals here between these two times from 1 to 3 p.m. I can say 1 o'clock, since these are counting by ones, I'm going to say my original amount is 50. So I'm actually going to say, well, it's about 50 and a half. So I'm going to say at 1 o'clock it was 50.5 degrees Fahrenheit. And at 3 o'clock it was 54.5. Well, I know that it's increasing, but how much is it increasing by is the real question. Well, what I can do is take the time at 3 p.m., which is 54.5, and subtract it from our 50.5 p.m. From our time from 1 p.m., 50.5 degrees. So if I subtract these, I can see that there's a 4 degrees difference. So it's increasing by 4 degrees. Sounds cool, but let's actually look at 3 to 5 p.m. because we want to see which one changed the most. So from 3 to 5 p.m., I'm going to say it's about 57 maybe, or sorry, 58. We're going to keep it consistent. We're going to say it's about 58 degrees. Now, if you put 58.1 or 58.2, that's totally fine. We're going to do the same process. So we're going to say 58 minus our 3 p.m. time, since it's 3 to 5, 54.50. If I subtract these, I'm actually going to get 3.550 or 5 degrees Fahrenheit. So 3.5 degrees of a difference. So as we can see, this time between 1 and 3 p.m. is a half a degree warmer than from 3 to 5 p.m. So did the temperature change between 1 and 3 p.m. or 3 to 5? The temperature changed more between 1 and 3 p.m. Now, if you want to phrase this a different way, that is absolutely fine. No worries. Now, the fifth question here, it says, does the graph show the temperature as a function of time or time as function? So remember, our temperature is on our y-axis. So is y going to tell us, or sorry, is our time dependent on our temperature, or our time, or our function determined by the time? So let me ask you this. If I said, hey, you know what, outside right now it is 52 degrees, or let's say it's, let me erase this. Let's say it is about, I shout out and go, hey, you know what, the temperature outside right now is 54.5 degrees. Well, can you tell me specifically if I just randomly told you that and ask you what time of the day could it possibly be? Could you tell me? No, absolutely not. Because look, even if I drew a line straight across, right? At some point, there's going to be 2 sets of time for my temperature. So I couldn't walk up to somebody and go, hey, at what time today is it going to be 60 degrees? With just knowing off the top of my head, minus phones and graphs and things, we couldn't tell. But what we could say is, hey, at 6 p.m. or 7 p.m., what is the temperature going to be at 6 p.m.? You can definitely go, you know what, at 6 p.m., it's going to be about 59 degrees. That's what we're looking for. And that explanation means my temperature is a function of time. So my temperature is dependent on the time, which is 100% true. Each day it'll be a different time, or each temperature will have a different time. So I'm going to say temperature is a function of time because we can find the temperature at any time versus knowing the temperature and then guessing the time. So right here it says when the input of the function is 8. So when I have 8 as a function input, so input is always x. What is going to be the output? Well, I know my inputs are time. And so what I can look at now is at 8 o'clock, because our input's 8, what temperature is it going to be? Well, if I go all the way up, looks like it's going to be 57 degrees. And if I was going to actually write this into words, because I can't just walk up to somebody and be like, yo, 8:57, 8,57, that makes no sense to them. Well, how I would put it, especially if you have no graph, you can't just look at the graph and go, what the heck is this? Oh, I see. Nobody's going to know. Nobody's going to know. So what we have here and how we're going to say it in words is at 8 p.m., the temperature, is or will be, depending on whatever you want to say, is 57 degrees. So sometimes in math we have to be very specific on what our writing is. So you could say the temperature will be 57 degrees at 8 p.m. That's totally fine too. But we want to make sure, especially if nobody has a graph, that we're explaining in words what the question is asking. So in this case, 57 degrees. At 8 p.m., the temperature is 57 degrees. So now we're going to move to our garbage here. It says the graph shows the amount of garbage produced in the U.S. each year. So we're going to have a second video here since there's a couple more slides. So take a moment, get everything down, and get ready for the second video.